It's very important in question number 6 that you notice we'll be using the full data set and we'll be using a random subset of 90. So let's go in here and go to our subset and close out our subset. We are going back to the full data set right here. We have the full data set open once again. I'm going to expand just a tiny bit. There we go. We have the full data set at 951, and we're going to do like we did in problem number one. We're going to go to subset. We go right here to random sample size, and we type in 90. We can call it my subset of 90. So we've even named it now. We have the subset of 90 right here. Good deal. So this is our subset of 90. We can just save it just in case. Nice and neat. Have it saved. So we have two data sets. Our data set of 951, denoted down here. Let's push this in a little bit more. There we go. And then we have our data set of 90. You can see how many there are and which data set you're using right down here in the bottom. Going to this question right here, from your random sample of 90, choose a categorical variable with exactly 2 levels and then go to Analyze Distribution. Pick one of these levels and report p hat, and then we need to calculate a 93% confidence interval for it. And interpret what it means in context. So let's go ahead to our subset of 90. Let's go to Analyze Distribution, and let's do male-female. You can do whichever one you want. I'm going to hit stack right here just so I can get it in horizontal layout. And now we need to add in a confidence interval by going over here and going to confidence interval and put in other, because we don't want one of those. We want a 93% confidence interval. Now remember, a 93% confidence interval is kind of like doing a test with a 0.07 alpha. That's an interesting thing that we talked about in class, that a two-tailed test would be the same as a 93% confidence interval with a 0.07 alpha. Good concept to remember right there. That's not related to this project, but could be on test 3. So looking right here, we have, let's say, the proportion of females from this sample. The sample proportion of females, p hat, is 0.45556. Sample proportion of females. With this in mind, we have a 93% confidence interval for the true proportion of females. Now, I'm not going to give you this exactly because I want people to come up with their own, but our interpretation would be something like, I am 95% confident that the something is contained in the interval between and So you need to give your own, and we're talking about the lower and the upper confidence interval here. Make sure you say exactly what you're talking about here. This is a little bit for you to think. What are we saying that we're 95% confident about? We're 95% confident that what is contained in the interval blank to blank. Very important question. When you think about it, we always do sample statistics to estimate population parameters. And make sure to give this question when you answer it in context of the problem. So we need to go ahead and take a snip of this right here. So let's go ahead, take a nice little snip. There we go. Nice and neat little snip. We put that into our project. Going back right here, from the full data set, use jump to display the population proportion for this same level, which the population proportion is what we're always trying to estimate with a confidence interval. So I go to my full data set. To display the population proportion, we can go right here to Analyze Distribution, and we can go to sex again, click it, and we're just going to stack it. Now, I want you to realize something here. If this is the population, we would not ever make a confidence interval. Confidence intervals are made from samples to estimate population parameters, because this is the truth. This is the truth right here. So we wouldn't make, because we're saying this is everybody, 951 people in the whole population, and it is true that there's 50.7% females. Does that match our confidence interval? Let's get them both on the screen right here. Where our confidence interval estimated that the true proportion of females in the population would be between 36 to 55%. I'm just doing a little bit of rounding. And yes, the true proportion of females in the population is contained in the confidence interval. We need a picture of this too up here. So let's get a picture of the truth from our population. So we could put that in our output. And once again, make sure you only make a confidence interval for the sample down here, because sample statistics estimate population parameters. Because this is when we don't know the truth. We go out and we sample 90 people, and we meet the 10% condition because 90 is less than 10% of 951. These people were taken randomly and independently, and as it says in the project, JUMP doesn't need the success failure condition, it uses more advanced algorithms, but we would meet the success failure condition here anyways. So let's look back here. Does your 93% confidence interval contain the true population proportion P? Definitely. And I would state that P, 50.7, is contained in the interval 36.3 to 55.05. Definitely contained in there. Your intervals may or may not contain it, but what percentage of your classmates' intervals would you expect? And this is where the understanding of confidence intervals is important. When we go from a 93 to 95 to 97 to 99, the confidence intervals will keep getting wider. So let's go over here to confidence interval and make a 99% confidence interval. If you notice, it's now going from 32 to 58. So we would only expect, if you think about it, I'm not going to state the answer, I want you to think about it and how to phrase it. When we go to a higher confidence level, we expect more intervals to contain it. So at a 93% confidence interval, what percent of your classmates' intervals should contain it? Or at a 99, what percentage of your classmates' confidence intervals should contain it? Think about how you would phrase that, and in the context of this question, what percentage of your classmates' 93% confidence intervals would you expect to contain the true proportion P? So think through this carefully and write this up and make it look nice. Good job.